Hi, welcome to another session of Circuits and Networks. In today's class, we are going to see a simulation model of Matlab for circuit which is shown in this figure, where you can see a 12 volts DC supplying its input to 2 ohms, 4 ohms and 6 ohms, and we need to calculate the value of current in 4 ohms and voltage developed across 6 ohms. Side by you can see the Matlab model also. So how to connect all these elements in Matlab and how to get the value of current and voltage in a very quick way we are going to learn about this particular session. So you know that whenever we get this kind of circuits where whether we need to find out the value of current or voltage, what we are going to do, we are going to take the help of mesh analysis, node analysis, or you can also take the help of network theorems to solve the problem, or you can use any network regression technique. For example, if at all you solve this problem using mesh analysis, you need to imagine two loop currents like this, which are in clockwise direction, I1 and I2, where you are going to apply KVL to loop 1. Considering this circuit, I1 as loop 1, we are going to get the equation as minus 12 plus 2 I1 plus 4, I1 minus I2 equal to 0, which leads to a standard equation of 6I1 minus 4I2 equal to 12, making as this equation 1, and applying KVL to loop 2, we are going to get another equation which is nothing but minus 4I1 plus 10I2 equal to 0. And after that, with the help of calculations, normal calculations, you can get the value of I1 as 2.72 amperes and I2 is equal to 1.09 amperes. And overall, we need to get the value of current in 4 ohms. So here it would be I1 minus I2, that is the loop currents I1 difference I2 will give you the value of branch current, that is I4 ohms, as 1.63 amperes. And then we need to calculate the value of current voltage across 6 ohms, right? So voltage across 6 ohms can be obtained as 6 multiplied with I2, so that will give you the value as 6.54 volts. So we have seen many examples in our previous classes in order to obtain these sort of questions. And if at all you go with the node analysis, we have to assume a node voltage over here. We are marking here as V suffix AB as node voltage and applying KCL at this particular node. Therefore, higher voltage assumed to be at high potential and minus 12 divided by 2. This gives you the branch current over here. Then you have VAB by 4, another branch current over here, and VAB by 6 is equal to 0. Solving for VAB, you're going to get the value of VAB is equal to 6.54 volts. And what is the requirement of the problem? We need to calculate the value of voltage across 6 ohms, which is nothing but same VAB value, because voltage at this particular node we have calculated to be 6.54 volts. So the same voltage will persist over this branch. So anyhow, current, that is I4, would be the node voltage divided by the resistance 4 ohms, that will give you the value as 1.635 amperes. As I told you, voltage across 6 ohms is nothing but VAB, and we got the value as 6.54 volts. You can employ any reduction technique. You can go with the current division rule or voltage division rule in order to get these two values, and comment in the chat box whether you got the same value or not. Now our intention is to solve the circuit and get the values of current in 4 ohms and voltage across 6 ohms in Matlab model. So how do we do this? For this, going with the Matlab page. So here you can see you have a Matlab command window where I need to go for the simulation values. So I'll go with the new model like this. So open a simulation block with the help of library browser, and already the circuit is drawn over here. For easy sake, I'm going with the next untitled model like this, untitled one. So the requirements are nothing but the passive elements as well as active elements, right? So in the library browser, I am going with the first Simulink model, where you can see there are some blocks which are represented over here. So let us go with the sources, whether we require any kind of source over here. So we don't have any voltage source or current source in this particular sources section. So go for the sinks, where you can see there is a display over here, right? And you can have a scope over here. So we don't require a scope here. Why? Because we need a digital output, not a waveform. So I'll take this display and I'll add to the block model untitled one, right? Okay, that is added, fine. Then quickly, there are so many options given in the Matlab, but you go with the simscape. In this simscape, I'll go with the electricals, In this electrical, I have again sub blocks over here. So let me go with the specialized power system devices. Especially we use this specialized devices for electrical circuits and networks. So with this, what we'll go with the fundamental blocks, right? In fundamental blocks, you can see there is electrical sources. With this, I can have a DC voltage source over here. Fine. So I'll select this and add to the model untitled one. Okay, that is added. Fine. Now go back to the previous menu. There you have elements, right? And this elements, you can see there are n number of elements, but we require resistor. So I'll select this series RLC branch. Okay, and I'll add to the block untitled one. So that is also done. Then you can see in the help, search injection section, I have taken the help of power guide. So I'll click over this. When I going to press the enter block, I'll take this and I'll add to the block. Also we need to know the current value, so I'll add the current measurement. Then you have voltage measurement. So fine, all are these added to the untitled block like this. You can see over here I have taken all the sources in this way, and I have DC voltage source. So I'll take this value, and the value of DC voltage source where it is given as 12. So I'll take the value as 12. So I've done with this 12. Okay. Then you have RLC branch. So I'll click over here. You can see there is an RLC option. I'll go with the R option. I have 2 ohms first value. So I'll take the value as 2 ohms. Okay. Then with the help of copy and paste option, I'll take another resistance value, which is 6 ohms. Fine. And another resistance value, I have to flip it to the clockwise direction, and its value here is 4 ohms. So 4 ohms is taken, that is also done. And then now just simply you connect the blocks. So you can connect like this, you can connect like this. Okay, so this block is connected like this, and you can connect like this. So you can see our electrical circuit block is done. Fine. So these type of circuits often we see in different kind of textbooks or different kind of literatures when we go across KVL and KCL. So it's a T model. Okay, so you can check the values of resistance. One is 2 ohms, one is 6 ohms, one is 4 ohms, and the DC voltage source is 12 volts, right? Fine. Now we require current measurement across 4 ohms, right? So what I'm going to do, I'm removing this connection over here. I'm flipping over this block and rotating in clockwise direction so that it can fit in the session. You can see that session is fitted over here like this. Okay, this is a current measurement. So I'll take this display block, I'll add to the current block like this. Fine. And you have a resistance of 6 ohms over here. So voltage should be connected in parallel. So I'll take the voltage 1 terminal to the left of the resistor like this, and again to the right of the resistor like this, and I connect to the display block like this. Okay, so this is a session. Fine. Then we have to run the block. So I'll go with the stop time of 2 seconds and I'll run the block. So it's a very fast, it's very easy. As you know, we have calculated the value of current as 1.636, which is the current in 4 ohms, and the voltage across 6 ohms is 6.545 volts. So this is what we have done with the help of Matlab circuit. And likewise, if at all you are good at connecting these circuits as early as possible, as fast you can do all these things, then it is easy to solve any complicated circuit problem. Not only circuit problem, related problem, but also many subjects which are related to electronics, electrical, mechanical, or any other engineering. So you should know how to connect this simulation block in a proper way. So that is all for today's session under Matlab. So what we're going to do, we'll see this another example. You take this example where I have added another 10 volts of source into the previous circuits. Already the circuit we have seen over here, and just calculate the value of current through 4 ohms and voltage across 6 ohms, which already you can see the values are displayed over here. Okay, try to solve it using Matlab, and again check the answer with the theoretical approach, that is by KCL, KVL, or node analysis, and comment in the chat box whether you got the same answer or not. So with the today's session, we have calculated the circuit current and circuit voltage, that is across 4 ohms and 6 ohms respectively, using Matlab. And as a homework, I am giving you to solve the circuit when 10 volts is added into the circuit and get the value of current in 4 ohms, voltage across 6 ohms. Check the result using mesh analysis and node analysis, and comment in the chat box whether you're going to get the same answer or not. So that's all for today's class, friends. I hope you like this video. Share among your friends, subscribe to this channel, and press the bell icon for the future notifications.